Hello. I became interested in astronomy and space when I was just 7 years old, and I count myself very fortunate growing up in the 1960s at the time of the space race, this great competition between the United States of America and the then Soviet Union to carry out a whole series of space firsts. And this space race culminated, of course, in the landings on the moon, the Apollo program. It was probably always going to be natural that the moon would be the first place humans would want to explore. The moon is our nearest neighbour in space, our partner in space. On a rocket, you can get to the moon in 3 days, go there and back in a week. And the 6 Apollo landings that were successful were incredibly important. We brought back more than 1/3 of a ton of moon rocks, dust and soil, which are still being analysed today. Experiments were set up in the lunar surface, which taught us an enormous amount about the Earth-Moon system and the relationship between the Earth and its junior partner in space. But I think one of the most important aspects of those Apollo moon landings was it generated a worldwide interest in astronomy and space. And that was very, very important.
15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have commenced. We have
Right away, Houston.
The crew of Apollo 17 left the moon in December 1972. Since then, no one's been back. Now, after nearly 50 years, a new era of human space exploration is dawning, the Artemis Program. Here at the Kennedy Space Center in Florida, a giant new rocket and spacecraft capable of taking astronauts to the moon and beyond is being assembled. Artemis 1 will be the first full test of NASA's deep space exploration systems, the Orion spacecraft, Space Launch System rocket, and the ground systems at the Kennedy Space Center. Artemis 1 will be an uncrewed flight test that will travel 450,000 kilometers from Earth and 70,000 kilometers beyond the moon during the planned 26-day mission. The 100-meter tall Space Launch System rocket and Orion spacecraft will blast off from Launch Complex 39B at the Kennedy Space Center. The Space Launch System is designed for missions beyond low Earth orbit, carrying crew or cargo to the moon and beyond, and will produce 8.8 million pounds of thrust during liftoff to launch a vehicle weighing nearly 4,000 tons to orbit, propelled by a pair of 5-segment solid rocket boosters and 4 RS-25 engines. After jettisoning the boosters, surface module panels and launch abort system, the core stage engines will shut down and the core stage will separate from the spacecraft. As the Orion spacecraft orbits Earth, it will deploy its solar arrays, and the interim cryogenic propulsion stage will then give Orion the big push needed to leave Earth orbit and travel towards the Moon. Orion will separate from the ICPS about 2 hours after launch. For the journey to the Moon, Orion will be propelled by a service module provided by the European Space Agency, which will supply the spacecraft's main propulsion system and power, as well as house air and water for astronauts on future crewed missions. The outbound trip to the Moon will take several days, during which time engineers will evaluate the spacecraft systems. Orion will fly about 100 kilometers above the surface of the Moon, and then use the Moon's gravitational force to propel it into a new deep retrograde orbit about 70,000 kilometers from the Moon. The Orion spacecraft will stay in that orbit for about 6 days, and then do another close flyby of the Moon using a precisely timed firing of the surface module engine in conjunction with the Moon's gravity to accelerate it back towards Earth. Orion will enter the atmosphere at 11 kilometers per second, 25,000 miles per hour, producing temperatures of about 2,760 degrees Celsius, faster and hotter than Orion experienced during its 2014 test flight. After about 3 weeks and a total distance travelled exceeding 2 million kilometres, the mission will end with a precision splashdown off the coast of Baja, California. With this first mission in the Artemis program, NASA is taking the next steps in human space exploration, where astronauts will build and test the systems needed for lunar surface missions and eventual exploration to other destinations farther from Earth, including Mars. Future missions in the Artemis program, with crew aboard Orion, will assemble and dock with a so-called Lunar Gateway, an orbital outpost in the vicinity of the Moon, constructed with the help of industrial, commercial and international space station partners. The Lunar Gateway will consist of a power and propulsion element, the first component to be launched. This will use advanced high-power solar electric propulsion to maintain the gateway's position or move it between lunar orbits to maximise science and exploration operations. Habitation capabilities will further enhance the capability for science exploration and use by commercial and international partners. Adding an airlock to the gateway will allow crews to conduct spacewalks, enable science activities and accommodate docking of future elements. Crews will participate in a variety of scientific investigations, exploration and commercial activities in the vicinity of the Moon, including missions to the lunar surface. NASA plans to resupply the gateway through commercial cargo missions. Visiting cargo spacecraft could remotely dock between crewed missions. In support of the return to the Moon, NASA needs a new spacesuit for its astronauts that's more versatile, flexible and durable than any made before. When working outside the ISS, astronauts are floating in microgravity and need to use their hands to move from place to place. But moonwalkers working in 1/6 gravity will need to use their hands and feet, walking to destinations and bending and reaching as they explore. For this, NASA has developed a new design of spacesuit, the XEMU, which stands for Exploration Extravehicular Activity Mobility Unit. One of the most obvious changes is the way astronauts get in and out of the suit. It features a hatchback where astronauts simply slide in and out through the back of the one-piece body, rather than the current multi-step process where they have to wriggle into the upper torso and then be helped into a pair of space pants forming the lower half. Apollo astronauts had to hop when moving around, and it was difficult to bend to pick things up. In the new suit, they'll be able to walk, not hop, and have a much improved range of movement, mobility and comfort, with reduced potential for injury, including the ability to kneel down to pick something up. The astronauts will also be carrying a special backpack, the PLSS, which stands for Portable Life Support System. This is everything needed to keep the crew member alive and comfortable while they're on a spacewalk. It has an oxygen supply, pressure regulator, and a ventilation loop and a water loop to remove trace contaminants and carbon dioxide and maintain the temperature inside the suit regardless of the temperature extremes outside. With the Artemis program and all of the exciting developments it will require, there will be renewed interest in building bases on the Moon, for utilisation of the Moon's resources, in using the Moon as a base for scientific research projects and as a springboard for future human missions to Mars. The Artemis program of human space exploration is surely to trigger enormous interest. But we mustn't forget our robot explorers. We have sent intelligent robot space probes to explore all the planets of our solar system, their moons, rocky asteroids, icy comets, and objects in the outskirts of our solar system like Pluto. But one of the really exciting projects that's going on at the moment is the Perseverance rover exploration on Mars. It was on the 18th of February 2021 that the Mars Perseverance rover arrived at Mars after its journey and entered what we call the 7 minutes of terror. The so-called 7 minutes of terror is the time it takes from first hitting the Martian atmosphere at over 20,000 kilometers per hour to an eventual touchdown on the Martian surface. Landing a spacecraft on Mars is never easy, and this was the largest, heaviest, cleanest and most sophisticated six-wheeled rover ever sent to Mars. Hundreds of critical events had to execute perfectly and exactly on time for the rover to land safely on Mars, including deployment of the biggest supersonic parachute ever sent to another planet. The parachute and powered descent slowed the rover down to about 4 kilometers per hour. And then during the final 20 meters or so of its descent, Perseverance was lowered to the surface, suspended under a rocket-powered sky crane on 3 bridle cords to land softly on the floor of Jezero crater.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Billions of years ago, this now bone-dry 50-kilometer wide crater was home to an actively forming river delta and a lake filled with water. So what has the rover been doing since that landing in Jezero crater? And what are the plans for the future? The Perseverance mission has already achieved a series of firsts that will help future generations understand more about Mars in particular and our planetary system in general. An important milestone was the collection of the first rock core sample, with the science team looking down the tube when it was still in the drill bit and confirming that the sampling was a success. Now that samples have been collected, everyone wants to know when and how they'll be brought back to Earth for detailed analysis. But we shall have to wait for a future mission to pick up the samples in their sealed tubes and ferry them back to Earth to see if any show signs of ancient life. Now that they've toured the floor of Jezero crater, the science team looks forward to investigating the branching delta that formed from the mud, silt and other flows brought down by the inflowing river, through the breach in the crater wall and fanning out onto the crater floor. It is in these deposits that we might find evidence of ancient microbial life. Another highlight of the past year was seeing the successful deployment of the Mars helicopter Ingenuity and experience the first powered flights on another planet. The helicopter team had to adapt to the environmental changes to keep it flying, and the helicopter has become a real asset to the science team, providing a completely new way of exploring Mars with its bird's eye view of the surface features. So let's look at how Perseverance will conduct its future exploration of Jezero crater. This enhanced colour mosaic from the Perseverance rover allows the science team to walk right into the scene at the rover's landing site in the crater. This is a combination of images taken by the rover's Mastcam-Z instrument, so it's incredibly rich in detail. The blue sky is an indication of the enhancement the team have done to the image. If you were on Mars, everything would appear pink, including the sky, as shown here. The enhancement process exaggerates small changes in colour from place to place in the scene. This makes it easier for the science team to use their everyday experience to interpret the landscape. The mountains that you see in the background are the rim of the crater. They are more than 500 metres high and about 10 kilometres distant. That canyon was carved by a river about 3.5 billion years ago, when the climate of Mars was much warmer and wetter than the bitterly cold, dry climate of today. The cliff-like brown hills you see here are more evidence of that river. These are part of the delta. When the incoming river hit Lake Jezero, its mud and silt were deposited on the crater floor. One of the most scientifically interesting aspects of this mosaic is this whitish area here, which the science team has been calling the bacon strip, based on its appearance. They think this is a layer of mud deposited on the lake bottom, now turned to rock. That mud layer is important because it may be the best place to look for evidence of Martian life that could have lived in Lake Jezero long ago. The large boulders on the delta are another interesting target for investigation by Perseverance. The boulders very likely washed down from far up the river channel, from places too far away for the rover to ever go. They're a gift that allows us to learn about what's far beyond the crater. As soon as they're done with their investigations of the crater floor on smaller rocks like these, which are probably volcanic, the science team would like to move quickly to the delta. But unfortunately, Perseverance has to take a longer route to avoid these sand dunes where it might get bogged down. Mosaics like this one help us learn more about the ancient Martian environment and provide new clues to where to seek evidence of ancient microbial life. The Perseverance rover is just getting started on its long journey across the crater. Fascinating times clearly lie ahead. Now, human space exploration and exploration by robot explorers are two ways in which we learn about the universe around us. But of course, we mustn't forget the giant telescopes that we are using to probe the mysteries of the cosmos. We have giant telescopes on the ground, in deserts, on mountaintops, on islands in the middle of vast expanses of ocean. And those giant telescopes work round the clock to unravel the mysteries of the universe. But we also put telescopes in space. And for over 30 years, the Hubble Space Telescope has been sending back amazing images and rewriting the textbooks about the universe in which we live. But on Christmas Day last year, a brand new space telescope was launched. It's the largest, most sophisticated space telescope ever built. It's been a long time in the making. Over a decade we've been waiting for the launch of the James Webb Space Telescope. But now it's on station, about 1.5 million kilometres from the Earth, in a cool, dark part of space. And it will hopefully begin its work in earnest later on this year. The Webb telescope's journey to space began with it being shipped from California through the Panama Canal to French Guiana. It was then taken by road to the launch site facility at Kourou, where it was to be readied for launch atop a powerful Ariane 5 rocket. First, the telescope was carefully removed from the protective container into which it was packed for shipping at the Northrop Grumman facility in California. The James Webb Space Telescope, which is named after a former NASA administrator, is a large infrared telescope with a 6.5 meter primary mirror. Several innovative technologies have been developed for Webb. These include a primary mirror made of 18 separate segments that unfold and adjust to shape after launch. The mirrors are made of ultra-lightweight beryllium. Webb's biggest feature is a tennis court-sized 5-layer sunshield that reduces heat from the sun more than 1 million times. To fit the telescope inside the nose cone of the rocket, the telescope's main components had to be folded up like a butterfly inside a chrysalis. The main mirror was folded into 3 sections like a gate-leg table, and the secondary mirror on its supports and the giant sunshield were carefully stowed away. After mating the nose cone assembly housing the telescope onto the top of the rocket, it was taken to the launch pad. It's Christmas Day 2021 and we are go for launch.
2, unité, top.
And liftoff.
Décollage.
Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight, good pitch program reported.
Séparation des EAP.
We have confirmation of solid rocket booster separation.
The 2 fairings of the rocket's nose cone separate and the telescope is exposed to the space environment for the first time. The cryogenic main core stage separates from the upper stage of the launch vehicle and drops away. The cryogenic upper stage then fires to place the telescope on its correct trajectory away from Earth. It then separates from the telescope. Seen here from the camera on the upper stage, we see the James Webb Space Telescope gently moving away. First, the telescope's solar array is deployed. If course corrections are needed, these must be done early in the flight to most efficiently use the mission's limited precious fuel. After deployment of the communications antenna, the Webb telescope passes the orbit of the Moon. Next is the deployment of the Sunshield Pallets. The tower, separating the telescope and instruments from the spacecraft and Sunshield, is next. Then the aft flap deploys. This is key to managing momentum build-up and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its centre of mass. After the Sunshield pallets reach their final positions, the membrane launch restraints are released. The Sunshield protective covers roll back, permitting membrane deployment. The covers over the core region release next, then the mid-booms extend and the Sunshield assumes its hexagonal tennis court size and shape. It is now time to tension the Sunshield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, The Sunshield allows the telescope to cool to minus 236 degrees Celsius, cold enough to liquefy air, while the layer closest to the Sun is at almost 90 degrees Celsius, approaching the boiling point of water. Once in the shadow of the deployed Sunshield, the telescope and instruments continue cooling down to their final operational cryogenic temperatures. On completion of membrane tensioning, the secondary mirror deploys into position and is latched rigidly in place. The aft deployable radiator releases and springs into position, allowing the instruments to radiate their waste heat directly into space and away from the telescope. Disposing of excess heat is crucial to the mission so that it does not overwhelm the faint infrared signals to be collected from the universe. The two side wings of the primary mirror deploy and latch into place, completing the major deployments of the largest telescope in space. As the Webb telescope continues out to its operational orbit around the Sun-Earth L2 point, 1.5 million kilometers from Earth, the observatory continues to cool down to its final cryogenic temperature state. A trajectory correction, applied 29 days after launch, puts the Webb telescope into its halo orbit. Once the mirrors and detectors are sufficiently cold, the wavefront sensing and control operations can begin. This sophisticated multi-step operation's ultimate goal is to position each of the Webb telescope's movable mirrors into their correct final positions and orientation. Once the mirrors are aligned, the mission teams will continue checking out the science instruments, preparing them for operations. Webb's four main instruments are contained within the Integrated Science Instrument Module, or ISIM, which is the heart of the telescope. They have detectors that are able to record extremely faint signals, but to do this, the telescope's optics and scientific instruments and the detectors inside them need to be very cold to suppress infrared background noise. Typically, the longer the wavelength of infrared light, the colder the detector needs to be. One of Webb's scientific instruments, the Mid-Infrared Instrument, or MIRI, sees mid-infrared light at wavelengths from 5 to 28 microns. By necessity, MIRI's detectors need to be at a temperature below minus 266 degrees Celsius to operate properly. So Webb carries a cryo-cooler that is dedicated to cooling MIRI's detectors and control electronics. The other three of Webb's four scientific instruments see both the reddest of visible light as well as near-infrared light, light with wavelengths from 0.6 to 5 microns. The near-infrared spectrograph, or NIRSpec, has programmable micro-shutters which enable observation of up to 100 objects simultaneously. NIRSpec and the other two main instruments, the near-infrared camera, or NIRCam, and the fine guidance sensor, near-infrared imager and slitless spectrograph, or FGS/NIRIS, all have detectors which work at minus 236 degrees Celsius, and they can be kept this cold simply by virtue of Webb's innovative design, which includes the tennis court-sized Sunshield. The Webb telescope will be the premier space observatory of the next decade, serving thousands of astronomers worldwide. It will study every phase in the history of our universe, ranging from the first stars and galaxies to form after the Big Bang, to the formation of planetary systems capable of supporting life on planets like Earth, to the bodies in our own solar system. NASA's James Webb Space Telescope will be a game changer. Discoveries made by this observatory will rewrite textbooks, inspiring the next generation of future engineers and scientists. Now, there's no doubt that space exploration plays a crucial role in every aspect of helping us understand about the universe in which we live. But space exploration can also play another role in helping to safeguard the planet on which we live. The Earth, our home in space, is very, very precious. We know of no other planet quite like it, and certainly in our solar system, there's no other world that we can live on without needing a spacesuit. So safeguarding the Earth, not only now, but for the future, is very important. Spacecraft in orbit around the Earth are monitoring the Earth all the time, looking at the oceans, the land, the atmosphere, helping us understand the changes that are ongoing on our planet and how we can make best use of its precious resources. But what about protecting our planet from possible threats that lurk out in space? As the Earth goes round the Sun, there are other objects also in orbit round the Sun that pass us by. Meteors or shooting stars are caused by dust burning up in the Earth's atmosphere all the time. Occasionally a larger fragment of rock burns up in the atmosphere and a small piece survives to reach the ground as a meteorite. But what about larger objects? Asteroids. There are 850,000 asteroids out there in space, mainly between the orbits of Mars and Jupiter. But some of those asteroids move away from the main belt, and they are perturbed into orbits that cross that of Mars and eventually cross that of the Earth. And so there is the potential for an asteroid to collide with the Earth. Now, there are no large asteroids on a collision course with the Earth, only small ones the size of a city centre or smaller. And the good news is that even with the next 100 years or so, there's no asteroid that we know that's on a collision course with Earth, but we've only discovered about 40% of those smaller asteroids that could threaten the Earth. Safeguarding the Earth against a possible asteroid impact is known as planetary defence. And one of the things we'd like to understand is to know more about asteroids. What are they made of? How dense are they? How massive are they? Could we possibly deflect an asteroid that we discovered was on a collision course with Earth? And that is where an exciting new space mission called DART comes in. DART stands for Double Asteroid Redirection Test. And it's the first real planetary defence mission that's been launched. So let's find out more about the DART mission and how it could one day safeguard our planet. The mission objective of the Double Asteroid Redirection Test, DART, is to determine whether flying a spacecraft into a small solar system body at speeds of about 15,000 miles an hour could be a reliable way to deflect an asteroid if such an object were ever discovered to be on a collision course with Earth. DART is a spacecraft designed to impact an asteroid in a test of the technologies required to prevent an impact by a potentially hazardous asteroid with Earth. DART's target asteroid is not a threat to Earth, but the chosen asteroid system is a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future. While no known asteroid larger than 140 metres in size has a significant chance to hit Earth for the next 100 years, only about 40% of those asteroids have been found as of October 2021. The target for the DART mission is the binary near-Earth asteroid Didymos. While the Didymos primary body, Didymos A, is approximately 780 metres across, its secondary body, or moonlet, also called Dimorphos, or Didymos B, is about 160 metres in size. This is more typical of the size of asteroids that could pose the most likely significant threat to Earth. The DART spacecraft is an impactor with a mass of 610 kilograms that hosts no scientific payload and has only sensors for navigation, such as a sun sensor, a star tracker, and a 20cm aperture camera called Didymos Reconnaissance and Asteroid Camera for Optical Navigation, DRACO for short. DRACO will support autonomous navigation to impact the asteroid's moon at its centre. The Didymos binary system is being intensely observed by telescopes on Earth to precisely measure its properties before DART arrives. The two asteroids are separated by just over a kilometre. The primary body rotates once every 2.26 hours, while the tidally locked moonlet revolves about the primary once every 11.9 hours. On the 24th of November 2021, NASA's Double Asteroid Redirection Test DART mission was launched from the Vandenberg Space Force Base aboard a SpaceX Falcon 9 rocket. In the ensuing few hours, the spacecraft established communication with mission operators and successfully unfurled its solar arrays. Once launched, DART deployed its roll-out solar arrays, ROSA, to provide the solar power needed for DART's electric propulsion system. The DART spacecraft is also demonstrating the NASA Evolutionary Xenon Thruster commercial, NEXT-C, solar electric propulsion system as part of its in-space propulsion. The DART spacecraft will intercept Didymos's moonlet, Didymos B, in late September 2022, when the Didymos system is within 11 million kilometres of Earth, enabling observations by ground-based telescopes and planetary radar to measure the change in momentum imparted to the moonlet. DART is the first mission to demonstrate smart navigation, which means the craft will be guiding itself into the asteroid autonomously. About 4 hours from impact, Smart Nav kicks in, and it uses the imagery from the DRACO camera on board DART to discern Didymos A from Didymos B. A sophisticated targeting algorithm will differentiate between the two and ensure that DART is aiming for Didymos B. The DART spacecraft will achieve the impact deflection by deliberately crashing itself into the moonlet at a speed of approximately 6.6 kilometres per second, about 15,000 miles per hour. DART also carries a small CubeSat called the Lycia Cube, which is equipped with two optical cameras dubbed Luke and Leia. These will capture scientific data and inform the microsatellite's autonomous system by finding and tracking the asteroid throughout the encounter. The CubeSat will deploy 10 days prior to DART's kinetic impact, kicking out of its spring-loaded box at approximately 2.5 miles per hour. The Lycia Cube will then use its onboard propulsion system to alter its trajectory, offsetting itself so it flies past Dimorphos around 3 minutes after the DART impact. That delay will give the Lycia Cube the opportunity to capture images of the impact's effects, including the resultant plume of ejecta and possibly the newly formed impact crater, as well as the backside hemispheres of both Didymos and Dimorphos, which DART itself will not see. The images Lycia Cube captures will hope to provide spectacular testament of the mission's success. The collision will change the speed of the moonlet in its orbit around the main body by a fraction of 1%, but this will change the orbital period of the moonlet by several minutes, enough to be observed and measured using telescopes on Earth. In this short video, we've only been able to give you just a flavour of current developments in space exploration and a few ongoing space missions. Keep up to date, if you can, with these developments by looking at the websites of the major space agencies. Not just the US Space Agency NASA and the European Space Agency ESA, but all the other countries involved in space exploration: Canada, Japan, China, Russia. There are many, many contributors to the space exploration program. And we haven't got to wait very long for the beginning of one of the things we've talked about here, and that is the Artemis program. Because all being well, the first launch will take place by the end of April this year, when the Space Launch System and the Orion capsule blast off on their 26-day mission around the moon and back. Yes, it may be an uncrewed mission, but an exciting test and the beginning of a new era of human space exploration.